What if your home wasn't built by a crew, but grew like a living organism? Imagine a world where static scaffolding is obsolete, replaced by millions of tiny, intelligent agents that assemble structures from the molecular level up. We are entering the era of software-defined reality, where architecture finally becomes fluid. This leads us to a profound question. How can programmable matter, driven by AI and orchestrated by nanobots, fundamentally transform the future of construction logistics? This isn't just about building faster. It's about reimagining the very essence of how we create our world. By the end of this video, you will understand how this technology could solve construction's biggest problems and lead to cities that can adapt, heal, and grow. So what exactly is this futuristic vision? Let's start with a simple idea. Think of programmable matter as a kind of smart clay. It's matter that can change its physical properties, like its shape, density, or even conductivity, based on a digital command. Now, imagine nanobots as the microscopic sculptors. These are tiny robots, just billionths of a meter in size, that work together to arrange this smart clay into any form we desire. The AI is the master artist, giving the instructions that guide this entire symphony of creation. First, let's explore the science of programmable matter. How can a material be programmed? The core idea is engineering materials whose properties aren't fixed. Think of shape memory alloys, which can remember and return to a preset shape when heated, or electroactive polymers, which bend or stretch when an electric current is applied. These are the foundational building blocks. By embedding computation and actuation at a microscopic level, scientists are creating materials that can respond to stimuli, change their form, and perform functions on demand. But how do we assemble these materials with precision? Enter the nanobots. These are robots designed to operate at the atomic and molecular scale, typically between 1 and 100 nanometers in size. That's smaller than a virus. Their job is to be the ultimate construction crew. They can be programmed to perform specific tasks, laying foundations molecule by molecule, weaving conductive pathways into walls, or even performing intricate repairs from the inside out. A swarm of 1 trillion nanobots would be chaos without a conductor. That conductor is artificial intelligence. AI enables a phenomenon known as swarm intelligence, where simple agents following simple rules collectively achieve complex, intelligent behavior. The AI doesn't micromanage every bot. Instead, it sets the overall goal and the rules of engagement. This allows the system to optimize assembly processes on the fly and adapt to changing conditions in real time, ensuring the build is always perfectly efficient. So why is this revolutionary for construction logistics? Because the traditional way is deeply flawed. Think about it. Material delays, immense waste, and complex supply chains. A staggering 98% of megaprojects experience cost overruns, often by more than 30%. AI-driven nanobots change the game. Materials could be fabricated on demand, directly on site, from a base stock of elements. Supply chains become radically simplified. And because the construction is self-correcting, errors and delays are virtually eliminated. The potential here extends far beyond just building skyscrapers. For everyday life, imagine self-healing infrastructure. Roads that repair their own potholes, pipes that seal their own leaks, or buildings with walls that can change their insulation properties based on the weather, saving massive amounts of energy. And for a mind-bending future vision, consider space construction. Instead of launching massive pre-built habitats, we could send a small payload of nanobots and raw materials to Mars or the Moon to assemble entire bases automatically. Now, it's easy to get carried away. Let's ground ourselves and address some common misconceptions. First, many think this is pure science fiction, decades away. This is partly true, but the foundations are being laid now. At labs like MIT's Self-Assembly Lab, researchers are already developing programmable materials and 4D printing, where objects transform over time. The science is real, even if the application is early. Second, the image of a nanobot is often a tiny humanoid robot. The reality is far more abstract. These are molecular-scale machines, more like specialized protein molecules than miniature C3POs, operating in swarms of trillions. Finally, some believe AI in construction is just about automating a crane or a bulldozer. The true paradigm shift is that AI won't just automate old tasks. It will enable entirely new methods of creation, like self-assembly, that were never possible before. So let's bring it all together. Programmable matter, guided by AI and assembled by nanobots, is a system where we can literally program the physical world. It matters because it promises to solve the inefficiency, waste, and rigidity of modern construction. And it changes how we see the future by shifting us from building static objects to cultivating dynamic, resilient, and sustainable environments. The home that grows itself is no longer just a fantasy. It's the logical endpoint of this technological trajectory. We are only at the beginning of this story, writing the source code for the world of tomorrow. What are your thoughts on a future where buildings grow themselves? Let us know in the comments below. If you found this exploration of the future fascinating, please like this video and subscribe for more deep dives into the technology that will shape our world.